unmuted.
Well, hello everyone. I think we're about to get started with our webinar today. Thank you for joining us. I still see a few people are logging in, but we'll get started irrespective of everyone's time. Just a quick introduction to what this series is all about. It's the SSI user webinar series. We're going to, over the next several weeks, probably spaced around 2 to 3 weeks in between, generally speaking, we'll introduce a number of our latest products. These are intended to be technical sessions, so therefore we'll start with a brief introduction, product and presentation, just to introduce you to the topic, but then we want to focus most of the session on an actual product demonstration. During the demonstrations, in particular, questions are encouraged, but you could ask them during the webinar. Please submit them online in the questions box, and we've got a couple of people who will be monitoring the queue while our presenter is demonstrating. After the webinar, you're certainly also able to provide us with questions. We could go to the Augie Marine Forum for public discussion. There's a new Marine group if you're not aware, so I encourage you to check it out. We've also got the Nexus account for clients who are current subscribers. You can certainly submit us questions that way. That also provides you private conversation if you prefer. And finally, if you don't have a Nexus account and you'd still like to contact us directly, you can email product.management@ssicorporate.com. So just to introduce electrical, the electrical addresses 3 primary user requirements. We want to provide production output for shipboard installation of cable, such that they help meet electrical engineering guidelines or respect electrical restrictions, that kind of thing, and the cabling rules. Provide introduction output for the production output for the installation of the hardware required to support the installed cables. And finally, to provide the modeling, editing, verification tools required to produce the production output. So the whole idea is everything is in a 3D modeling space as well, of course. And we'll go through this during the demonstrations, but there's various phases to using electrical. Set up rules and the standards, allocate the required space for the electrical and the cableways, model the wireways, cable trays and supports, etc. Finally, to be able to route the cables and to inspect those results, and finally the production output for the installers. Benefits of electrical, well, basically detect issues early, interferences in space allocations, of course, effective change management such as Associative wireway network, the integrated design so that all the disciplines are in the same model, of course, and finally and result in accurate cable links routed in 3D. The industry trends overall is consistent with that. It's a number of industry trends such as the more complete designing in 3D. More and more clients are beginning their projects in 3D. We like that and encourage that. Increasing the electrical complexity due to reliance and proliferation of electronics, communications, power systems. Certainly vessels today have a lot more of that type of technology, and the sensitivities to them are more important. Effective change management throughout the design, production, installation, and verification. It's part of the value proposition of ShipConstructor, just complements that. We're seeing increased reuse of designs and sister ship projects, so we have a more complete design to begin with. Increasing distributed work between multiple companies and organizations, of course, as well. So contracting out multiple organizations involved with the design and the production of a vessel. Is everyone hearing me okay? I see a couple of comments. I can see some that says I can hear me okay. If you could just respond in the chat, that would be helpful. Just hang on here. Okay. Okay, great. Thanks. Client opportunities, just a couple of types. Basically, who should be interested, we feel will be interested in electrical. Of course, designers, shipyards, consider it an upgrade from the current and the HVAC license. A lot of our clients today use HVAC to do space allocations, but then don't do any further electrical in that space. Of course, the larger or more innovative shipyards where they have to do more complete designs and installations and all that. And of course, one of our major clients is the Navy. They're highly organized shipyards, and they tend to do complete design, including electrical. We'd like to see them adopt our product. Typical scenarios, current scenarios, if you're just entertaining the idea of electrical but aren't convinced you need to try it out, you use HVAC and that might meet your needs. Well, the space allocations with electrical are now a lot more flexible than they used to be. They're also more future-proof in terms of electrical usage, segmented bombs and reporting, and certainly you would need to upgrade from your current to adopt it. A lot of organizations just use basic Excel. Allocating space early saves changes, change once, not twice. So model, instead of the old cliche is, if you don't have time to do it right the first time, you better have time to do it twice. So the idea is to do more complete design earlier on. And then, of course, just if you don't do electrical, you could look at the client workflows, the benefits of early space allocations at the very least, and some of the model drawings to at least initiate that design. In terms of ShipConstructor electrical availability, it has been available since 2012 R2 in some forums. Each release subsequently has improved the product or added to it. That's certainly our intention and functionality. It is available as an individual module, but it's also available within, you'll hear more about it in the year to come, about our product suites. Our product suites are really designed for small to medium-sized organizations with medium to large projects, but it is included in that as well. And so now I'd like to get on to the workshop demonstration. Again, feel free to ask questions during the session. Use the question chat and the GoToWebinar, and we'll keep monitoring that. I'd like to hand this off now to Blair, so just give us a moment while we handle that. Go ahead, Blair.
Okay, can you hear me?
Yes, I can.
Okay, welcome everyone. I'm glad to have you join me for the presentation of electrical today. My name is Blair Johnston. I'm a technical product manager at SSI, and we'll be giving you a brief tour through electrical modeling primarily. So I'm expecting our time to be somewhat tight today, so I will try to monitor the questions. If we are getting tight towards the end, then I may put you off. So as Norm suggested, please use one of the channels he made available, Augie Marine, Nexus, or the product management website, or sorry, email to pass on your questions, and I'd be more than happy to answer them. So I'll start right into it. So as you can see, I'm starting with just a sort of basic wireway drawing. I've got my ribbon open. This is in the electrical tab. And you can see the different sections across the top. And we're going to go through these sections pretty much in order here. Space allocations, cable supports, cable spaces. So the electrical consists of two primary parts. The first is modeling the actual physical wireway. This is the network of space allocations that both reserve space for the electrical as well as create the pathways through which the cables will be routed, and then the actual routing of the cables through those pathways. So first on the list for the modeling is space allocations. And space allocations are the foundation of wireway modeling. Pretty much everything you do in electrical will trace its way back in some form to space allocations. The design intent of space allocations was to make them lightweight and flexible. So if you've used HVAC in the past for modeling space for your electrical, the intention of space allocations is to give you more options, more flexibility, and to give you parts that are more lighter weight in the model. They connect together so, to form the network. So as you model and connect your space allocations together, you'll be building up that network through which you'll eventually be routing cables. Space allocations are organized into, or perhaps classified into, space allocation groups, and that's the only catalog aspect for space allocations. The space allocation groups are just a simple grouping mechanism for them, and they also provide the color that's used for modeling. So in the diagram we're looking at here, you can see that there are two colors that are used, the blue and the yellow, and that color is determined by the space allocation group. So we're going to start out, we're going to do some quick changes or additions to this drawing here to show some of the space allocation actual modeling. So we're going to start with a simple straight tool, and I'm going to just extend onto, click on the connection end on this space allocation, and we'll just drag it out. So it's a simple mechanism for adding space allocations to the model. You can see when I click on the connection end, it's added this green rectangle around the connection. This tells me that those two space allocations are now connected, and this means that I will now be able to route cables from the existing part of the wireway to the new part that I just modeled. Now what we're going to do is I'm going to extend this section out and around the one that we just added out here. Now I've used just a simple polyline as essentially a jig for my modeling. This one happens to be calibrated so that the space allocations I produce will actually fit these cable supports, the trays and hangers that I'm using in my model. So I'm going to use the bent tool to do this. So I'm just going to drag it out. So, and I've got my space allocation. So if we just do a quick look so we can see, and that's using essentially offset routing. So I could have used structure or any other snap points that I had in my model. If I had some structure M-linked in, or I had part views loaded in the model, then I could have used those as reference as well. So again, on the theme of being sort of lightweight and easy to use, in this case I used polyline to provide this sort of structure to go underneath the space allocation that I had. I could duplicate that polyline if I needed to do another run of a similar type under similar space allocation. I can also use the plain AutoCAD copy command, and it will copy my space allocations as well, and I could bring out add more space allocations exactly as I had, and I can use that as my template. So whichever way works for your modeling, whichever is the fastest, but that's the goal here. So we'll add a little more onto our space allocation model. Just add a few more. Now you can see also the familiar navaid to anyone who's used pipe and HVAC. The navaid just helps you limit the rotation of your objects to specific points or angles. So in this case, my T is currently constrained to one side or the other. So just reusing elements of ShipConstructor that are familiar to our users. So once we've got some of our wireway in place, then it's inevitable that eventually we'll, for one reason or another, decide that we need to make changes to the wireway. And again, for users familiar with pipe and HVAC, space allocations are built on top of the multi-part transform engine, which allows me to make modifications to the parts and have the wireway adjust itself accordingly.
Hey Blair.
And also, sorry, yes?
Got one question. Might as well keep it current. Can this space allocation take the routing of the polyline?
I'm not sure I understand what you mean. You mean just simply click on the polyline and say follow the polyline?
This question's from Octavian. Maybe you could elaborate.
Okay. I'm not seeing that one. So I'm not seeing, Octavian, the question that you're asking, but if what you're saying is, can I just simply use a polyline as a model and say, just essentially pick my stock and then have it follow the polyline? We currently don't have that, no. As you saw, I was using the polyline for snap points and providing that along the way.
Okay, we clarified, yes, routing like a pipe.
Okay. So yeah, so we were showing the flexibility in terms of changes using multi-part transform. It also uses similar mechanisms to constrain the multi-part transform. As you can see, I've got this elbow anchored up here, so that prevents the multi-part transform from propagating beyond that point. So it only let me adjust these portions of the wireway. Another aspect that's important in the space allocations, and we touched on this a little bit earlier, is connectivity. And one of the things, again, referring back to HVAC modeling of electrical, you were quite constrained there in terms of the connections that you made. And also you weren't building up the connectivity network. So with space allocations, because we need to be able to route cables sometimes in places that are awkward to model for space allocations, we've made the connectivity between space allocations as flexible as possible. So what we can do here, I'm just going to switch visual style so we can see inside here for a moment. So you can see most of my network's built up of directly connected space allocations. So that means each endpoint is laid on top of the other. In a few cases, I actually have these lengthened connections where one space allocation end is not directly on top of another. So this allows me to say, okay, I have a tray here, I have a tray here, maybe one's coming from the side and we'll have to drop down. And these allow me to make these connections across these networks without having to do any awkward modeling. When you're routing cables, any cables that are routed across those connections, the length of that connection is included as part of the length for that cable. So we do factor it into that. To make those lengths, those connections, as you see, this arm here that we've been working on is actually a disconnected portion of the wireway. So all we have to do in order to connect it to the wireway is bring it up and connect it across. So if we zoom in, now we can see now cables routed from the main branch can now, if need be, can come across to this side branch that we've been working on here. Now in this case, I connected directly to a connection end, an existing connection end in one of the space allocations. It's also possible for me to branch, similar to saddling with pipe, to branch into the middle of a space allocation. So I can click on this end, and I'm going to just use my nearest OSNAP to specify into the middle of the pipe. So this is the space allocation. So in this case, again, for the example, I might have a tray coming from the side and it'll drop down to one that's slightly lower. So I don't necessarily have to break the space allocation at that point to get a connection end. I can just simply connect into the existing space allocation that's there. So I'm finishing off the space allocations now. Norm, did you see any other questions?
Yes, Jaco's got another question. Is the polyline drawn to fit standards for bend radiuses, or will the standard fitting to use only two perpendicular lines or two parallel lines which are offset? So
I'm just trying to read here.
I could repeat that. Is the polyline drawn to fit standards for bend radiuses?
Oh, sorry. No, Jaco. The bend radiuses aren't directly supported right now. We've tried to get feedback from users in terms of how we could sorry, I think I got muted there for a second. How we could incorporate bend radius into what we're doing. And the problem that we have is that the bend radius that a cable will affect the cable will depend on where that cable lies in the wireway, and we're not tracking that. So if you're going around a bend and the cable's on the outside of one, goes into a T and is on the outside of the other, will be quite a different radius than if it's along the center or towards the inside of that corner. And also the person laying the cable has options such as bending the cable before it actually reaches that corner. So if you have an idea of a way we can tackle that, I'd be more than happy to hear from it, because it certainly is a request, and it's one of the things that would be nice for an automated tool to do. We just haven't had enough customer feedback to say this is how we could reasonably do it in an automated fashion. So I hope that answers your question. Sorry, I'm pausing with the questions here. For some reason on my display they're coming in a mixed order, so I'm having to scan through them. So I'll rely on Norm to jump in and interrupt me if need be to do it. But I'm going to rush along here because I'm definitely getting behind. So next on my list is cable supports. So I'm going to switch back to conceptual mode, just because it will show up a little bit better. So cable supports they're defined in the catalog, similar to the way that equipment is defined, so using standard drawings. The commands that insert cable supports are designed to help speed the insertion, especially in straights, by aligning the support as it's being inserted with the space allocation that it's going into. And we'll see this in a moment as we insert one. So we're going to start, in this case, we're going to take this straight here, we're going to put a tray inside it, and then we're going to add some hangers to support the tray. So up on our ribbon, we have the cable support section, and this gives us the commands related to cable supports. So there are two commands that are used to insert supports. The first one is it inserts one at a time in a serial fashion similar to the way AutoCAD copy works. The second one inserts a string of supports in a row separated by a fixed separation distance. And we'll show both of them here. So I'm going to select the space allocation. Now I'm going to pick a stock. I'm going to filter down my list. So I'm in my pick dialog here, and you can see some of the properties. Since we haven't shown you the actual catalog, you can see some of the properties that are available for cable supports in the catalog. And you also see here the profile, the preview. And so this is a long straight tray, and you can also see green circles indicating insertion points that I've defined on the stock and the CG point here. So I'm going to pick this one, and we're going to put this one into the tray. So again, as we had the insertion points defined in the catalog, so I'm going to switch to the one I want. And I'm just going to turn on my profile corner snap points, and that will allow me to place it directly into the corner of the space allocation that I want to get it into. So assign my assembly, and now we can see inside the space allocation I've got my tray. So now we're going to put some hangers into this to support this tray. And just to do this, just to extend the command a little bit or make it visible, when we insert by array, it works across multiple straight space allocations potentially, so one or more. So I'm just adding this one here because I'm supporting the tray, but I just want to show you the run going a little bit further on. So now the first thing we're going to do is select the space allocation, and I'm just going to zoom in here to show you when I picked that space allocation, the first thing it did is drew arrows at one end of the space allocation that I selected, and it picks usually the end closest to the point I picked on the space allocation. If it turned out I got the wrong one, I just click the space allocation again, and it toggles onto the other end. And then I can click other space allocation straights connected to the one I'm working with if I want to extend the insertion range beyond where I was at, or beyond the one I started with. So these are the space allocations I'm going to use to insert into. Now I'm going to select the starting point for my for the run of cable supports that I'm going to insert. I'm going to change my stock. that's the one, yeah. So what we see here is a hanger for the tray that I've inserted already into the model. And you can also see, again, the insertion points here are defined in the middle of this hanger, because this is a hanger provided by a third party, and it's designed to fit around this tray in such a way that clips are added onto the cross tier to secure it to the tray. So we're going to use this one, insert it into our model. Now, because of the stock that I had ahead of time, I'm going to have to manually specify the, oh, sorry, not the stock. I have to redo this one. So I got the wrong subcommand there. What I need to do is specify my insertion period. And now I'm going to switch to the insertion point that I want to use for this. So this will match up. I started with this corner of my space allocation, and I'm going to match that up with the insertion point I've selected on my stock. And now I insert the range of cable supports, specify the assembly I want those to go into, and I'm just going to take the default. And now you can see my run of supports, of hangers to support the tray. So I'll just briefly turn off the space allocation so we can just see that we've got a tray and the hangers in the model. So Norm, are we okay for questions? Oh, I think I've got my questions sorted here. So
Fine right now, yeah.
So I don't see any. We've got 2 pair lines. Yeah. Okay. So we're going to move on now to cable spaces. So we're sort of transitioning a little bit here. The cable, up till now, we've been working with the physical side of the wireway, the space allocations, reserving space, building the network, the supports being the actual parts that will be added to the ship to support the cables. From here on in, we're starting to shift towards preparing for cable routing. So cable spaces are the mechanism in electrical for managing the EMC separation and for calculating cable fill. So for now, they're only supported in straights. And we'll go in. Now, let's see, what's my time check here? 29. I'm going behind, so I'm going to skip for now the actual modeling of the cable space. I do have one in my model already. So in the ribbon here, we've got the cable spaces, and we'll turn those on. So and you can see, if I go up a little closer, inside the space allocation that I'm working with, there's a red rectangle, red box inside that, and that is that's a predefined cable space. And I was hoping to actually show you modeling of that. And if I do have time at the end, we can go back and do that. But for now, the command that I use to do that is the edit cable space command. And the cable spaces, they're essentially a property of the cross-section of the profile of the space allocation. So as space allocations extend or shrink, the cable space will expand or shrink with it. That doesn't apply for the profile, though. However, oops, sorry, I got my mouse going a bit crazy on me here. So, but what I will do now, so once I've modeled one of my cable spaces, then the next thing I need to do is get that into other space allocations in the wireway. It takes a little bit of time to set up the one because you want to have it aligned appropriately with the tray or the T or trapezes, whatever types of supports you're using. But once you get the first one set up, you can use it as a template and then simply copy that cable space to all other space allocations in the drawing that have the same profile. So and that we'll show that here right now. So I'm going to use the command up here, copy cable spaces to space allocation. And it's going to prompt me first for the space allocation I want to use as a template, and that's the one that already has the space allocation. And then the next one is to specify the space allocations that I want to use as a or I want to actually copy my cable spaces to.
We have another question there for you, Blair. The length of the rods and the supports have a value or is adjustable?
No, as I said, so we're talking about cable supports here. Yes, we're going back to the last topic, and you're talking about the downcombers on the hanger, and they're not adjustable. They're modeled in a standard drawing as a separate part. So when I was inserting one of the things we looked at there, and I'm sorry, I'm a bit tight on time to go back and actually pull up the dialogue, but when I filtered down to my part type, I had 3 different downcomber lengths. So I picked the particular one which was 18 inches for this one. I had a couple of others defined for this particular part type, but those do have to be predefined. Okay, sorry, I'm copying here, so I'm going to restart the command. So I'm picking my template space allocation, and let's see if I can get my run. Now I'm selecting the space allocations that I want to copy my cable spaces to. So I've used one as a template, and now I'm going to copy it to the selected space allocations. Now, as I said earlier, only straights support cable spaces for the time being. In some of them it just doesn't really make sense. In a T, because of wires crossing, it doesn't really have value. In elbows, there's a possibility that that might have value. For the time being, though, it's in straights. So now, as we can see, all of the straights of the space allocations that I selected now have cable spaces in them. So that's cable spaces. Now, in terms of managing the EMC, it's a little bit harder since we haven't actually shown you how to draw them in the space allocation. But basically, when you're defining the cable spaces inside your space allocation, you define it by drawing the profile shape on the space allocation, and when you set up your rules for incompatible EMCs, we won't let you draw cable spaces of incompatible types in such a way that they violate the rules that you've set up. The EMC, Ken's asking a question here, what is EMC? So if you don't know, this is the electromagnetic compatibility, I think, is the C. And so this is the rules that govern for what signal types will interfere with or can be interfered by other signal types in your wireway. And so this requires you to have certain, like, high power, high voltage lines will obviously interfere with sensitive lines like antennas and control cables, that type of thing. So you define your own EMC rules. So the types of EMC ratings that you want to use, they can be as simple as power and control, or we'll take a look at one a little bit later, I think, when we get into the setting up the cable routing. And we'll actually see the tree of how these are set up. Okay, so I think we'll move on to the next section. So the last section in modeling the physical wireway is legs. And legs group the parts of the wireway into named sections. So when we're routing cable, as we're going through portions of the wireway, each of these space allocations has a name, but we don't want to list each of those names in our cable route for where the cable goes. Instead, we want to have possibly as little as one name for this portion of the wireway. And that's what the legs provide, is a way of grouping multiple space allocations under one name, and that name becomes the language for routing cables, both when you're actively routing the cable and when you're printing off the cable schedules or pull sheets. In modeling the legs, we try to make it simple easy to because the legs define a set of space allocations between decision points, and a decision point in the wireway is any place where, coming from one point, there's an option for where a cable could go. So if I was coming up from along here, a T is a decision point because the cable can go one way or the other. I also have decision points anywhere where I've added more than one connection to the end of a space allocation or branched into the middle of a space allocation. All of those form decision points, and the legs define portions of the wireway between those decision points. And rather than have to select each of the space allocations to make up that leg, we actually make it a little bit easier by automatically selecting all the space allocations that are possible for that leg. So I'm running here the insert leg command, and all I've done is hover over a space allocation at this point, and it's automatically highlighted all of the space allocations that will be part of that leg if I click on this. And it would be similar for other parts of the wireway. I can define my leg. I can go up one by one, go through these, and define my wireway. So we'll just do one here. So, and what it's done now is, as I've defined my leg, I'll zoom in a little bit closer so you can see, it's defined these sort of spool brake-like icons at each end of the leg. So we refer to these as the leg brakes. Now you'll notice that in talking about the decision points, that the leg stopped at the T portion and it stopped at the end, the connection end that has more than one connection to it. So I've got a space allocation connected here, and I've also got this lengthened connection that branches over to the main line. So my leg ends at that point. Now I can quite easily simply add a leg to the other side and continue on. So now a leg routed from here across to here would show its route is going from L1 to L2. So another aspect of leg modeling is that we try to make it a little bit easier to adapt to changes in the wireway. So one of the things that happens is I might add parts to my wireway. If I want to extend this route, for example, maybe it was an end and I want to add a portion of the wire portion to it, I can actually add an elbow, and now you can see the leg automatically extended itself to the end of the elbow. Since there's no decision point at this part of the wireway, it's just automatically extended itself on. And this would go further if I added more straights or elbows or transitions. If I try to add a T, then I'm getting into adding a decision point, so the leg does not extend beyond that. Similarly, if I delete a portion of the wireway, then the leg adapts itself, shrinks down, and to what remains of the space allocations that were there. So I think that gives us covers what I wanted to get through for the leg modeling. One other thing, when we're modeling the legs, the other thing we have is a common requirement when working with the electrical will be to locate legs. So perhaps someone said, I need to make a change in this such and such a leg, and you need to find it. So the leg manager will show me all the legs that are defined in the drawing that I'm working with, and it allows me to select, and then I can highlight. So if I'm looking for by name, and I can also use this familiar sort of center highlight zoom controls. So at this point, we've modeled our physical wireway, and once we complete the process, we'll have a network of space allocations built up for routing the cable through the ship and supports at which the cables will leave the wireway. So now we're going to move on now to cable routing. And to show that, I've got a slightly more built-up drawing that I'm going to use. And this is a cable drawing. All cable routing is done in cable drawings. These are read-only views of the wireway, so you can't actually change the wireway here. All you can do is create cables. What they do allow you to do is combine portions of the wireway into one drawing. And if we look here, I'm going into the Space Allocation Manager here, and we can see in this particular drawing, I've composed this drawing from 3 other wireway drawings in my model. I could also use space allocation groups as a way of loading space allocations into my drawing, or I could also select a volume, a particular volume to load. And you also don't have to have all of the wireway required in order to connect the pieces that you want to route. So for example, if I was routing a control cable from the bridge to the bow of the ship, say the winch anchor, I would only need to load the bridge portion or a portion of that part of the wireway and a portion of the bow, and ShipConstructor, that gives me enough to specify to the cable router what it needs, and it can go find the route through portions of the wireway I've not loaded. As long as that network is built up in your electrical model, it'll find the route through those space allocations, and then once the cable is created, it will actually load those into your drawing, the space allocations along the cable. So when we say in electrical that we're routing a cable, what we start with is a connection, and the connection is defined as a logical connection between 2 equipment parts, and this is done in the project equipment list. So I'm going to just switch over quickly. So on the ShipConstructor tab, we have the project equipment list. Now I don't have time here to go into the detail of the project equipment list. If you haven't explored it yet, I encourage you to do so. But a quick view of it is all of the line items in here represent actual parts in the model, so we're not talking about stocks. These are actual parts. And it's in here that I actually define the connections between the electrical connections between these parts. So in this case, I'm looking at an existing connection. So if I select one, I can see the connection that I have here, and I've specified a cable group for it. So cable groups are a way of, these are a way of, this brings together the EMC ratings that we were talking about a little bit earlier when modeling our cable spaces. When we create a cable space in the model, we assign it a cable space type. And the type is a set of named properties that are applied to that cable space. And I had hoped to show you that, but we don't have time, I don't think, today. But one of those properties is the cable group. So we assign a cable group to the cable space in the wireway, and then we assign cable groups to the connection when we're defining that. And then when we actually go to route the cable, electrical takes a look at the cable that we're trying to route, the connection that we're trying to route, looks at the cable group that's defined, and then finds compatible pathways through the wireway network that you've defined to get from one piece of equipment to the other at the points you've specified. So I'm looking here at the EMC and cable group model that's been defined in this project. These are all user defined. The top level ones, in this case all ones that start with a number except for inert, are actual EMC ratings that I've defined. And then within each EMC rating, I've defined a series of cable groups. The cable groups are simply logical ways of dividing up your wireway. They don't change or alter the EMC rating that it's under. The same separation distances that you defined for those EMC ratings apply. But it does allow me to further segregate cables, so it gives me finer grained control over routing. So for example, I might have a digital EMC type, and then under that I might have cable groups of LAN and phone, and I might want to keep those 2 cable types separate when I'm routing. So all the cables of one type go in one tray, and all the cables of another type go in a separate tray. And that's what the cable grouping allows you to do. My tree here is only 2 definitions deep. If you really want to, you can go as deeply as you need to get the grouping you want. Cable groups specify, the cable space groups can be assigned at any level in the tree, and cables at that level or lower can be routed through that cable space. So we've got our connection. To create a new connection, we simply select two equipment parts in the PEL, go down and say make new electrical connection, and we provide our EMC rating and a cable stock. And I now have a connection that's ready to route. I didn't change the name on that one, but we'll find that one. So we're now ready to go and route that cable. So I'm going to go back to the electrical tab on the ribbon. And we're in the last section on the ribbon, the create edit cable command. And the first thing it's going to do is ask me for a connection to route. So these are the connections we were just looking at between equipment parts in the project equipment list. No, I'm not sure why it's not letting me select that one. So we'll route this one. So two things happened when I selected my connection to route. The first and sort of more obvious one was it's brought up the cable editor. So this is an AutoCAD palette, and it's organized into a couple of sections. And for specifying my run, the first is where we define endpoints for the cable. So as we said, the connection connects two equipment parts. At each end of that connection, we have to get from the wireway to the equipment part, and then on the other side, the other half of that. So in here, we specify the entry point into our equipment part. So the equipment parts have the ability, in order to use them for electrical, you have to define electrical entry points. These are defined on the stock similar to the way that you specify pipe connection ends or HVAC connection ends. So they're physically placed at a certain point on the equipment stock. So I pick the entry point, and then I pick a cable support to leave the wireway at or to enter the wireway at, depending on which way you're looking at it. So I'm going to go from this hanger here. Now the other thing that I skipped over that part or didn't cover it. The second thing that happened when I selected my connection to route is it loaded the two part views at each end of that connection. So the connection we defined was to define the connection between these two boxes. So in my first connection end, I've said, okay, I want to leave the wireway or enter the wireway at this support, which picking that support defines the point in that space allocation at which I'm jumping into my wireway. And then I want to go to this point on my equipment stock. And the other thing I have to provide is a allowance for the local run, the actual cable that goes between the two, or between the wireway and the equipment part, this entry point. And we'll do the same thing for the other side. So now I've fully defined the cable run as far as I need to right now. It knows where to leave and enter the wireway. It knows where those cables are going on the other end to the equipment parts. The other thing I can do before I actually go and route my cable is I may want to restrict or I may have an idea for specifically where I want, at least in part, where I want that cable to go. So for whatever reason that I know, maybe I want to keep my wireway, I want to keep some space reserved in one part of it, so I want to keep the cables all in another part. So I can influence the routing by using waypoints. And waypoints select a leg, because again, legs are the language of routing. So I'm picking this leg, and so it's showed, essentially I'm building up my specification for the cable route here. So I've got my entry and exit supports, and now I've also added this waypoint. So this leg I want my route to go through. So at this point I can click on Find Routes, and now it will come back and it's actually found a route through the network, and it's given me the list of legs through which that cable will pass. So this is the actual list of legs, and the other thing that it's done is for each leg it's assigned a cable space. So this goes back to when we were defining the cable spaces in the wireway, we said there was the potential for having more than one cable space, and in some of the wireway in this model, I do have more than one. Some of the ones just have one, so assigning it was the only option that it could choose. In other ones, however, we actually have, let's see, more than one. So I have control and power. So in this case, it was a lighting cable, and the lighting in the tree that we had of the EMC types and the cable groups, power was compatible, the lighting was compatible with the power cable space group. So that's the one that it's assigned, and it's gone through all the way through. I can change it here if for some reason I want to. Maybe I want to, I know that this is incompatible right now, but I'm going to go and change that to a different type later. I can do that if I want to, but by default it assigns the one that's most compatible. If it cannot find a compatible cable space, then it will assign none, even if there are ones available. In this particular one, I believe there actually aren't any defined in that leg, which is valid. In that case, there's simply no EMC control and no fill monitoring. But in other respects, the routing is perfectly fine. So now I can do keep route, click OK. So we finished routing. And now what I'm going to do is I'm going to use the cable manager. And so this allows me, similar to the leg manager, I can now select my cables, and it's not terribly easy to see with this model, but we can see if we zoom. So this is the polyline that's representing the cable through the wireway, and the pathway goes through here, up through the leg that I specified over here, and then find its way up and over to the support at the other box. So now we've actually gone full, I'm not sure it's quite full circle, but we've covered the gamut of working from building up the wireway model, defining some of the physical elements of constraining the wireway for EMC, and then actually routed cables into the wireway. So that's the end of the demonstration as far as I've got it. And I've got about 5 more minutes. Norm, do you sort of agree with that time?
Sure, yeah. People are
okay. So
if you want as well.
Yeah. So there's I can take any questions, and I can also go back and show you. We didn't finish actual modeling of the cable space, so I can go back and do that if there's a desire to do that.
The question here, is there a way to know when the cable tray is full?
Yes. So there's 2 ways of doing this. You can monitor this in the drawing, either the cable drawing or in the wireway drawing. There's a show cable fill, and so as I said, the cable spaces are the means for monitoring the cable fill. So I can only do that if I don't have a space allocation that has cable spaces defined in it. I can't monitor the space in that space allocation. The other thing that we do is the fill is actually monitored at supports. So for the case of a hanger, it's fairly straightforward. What we do is we project the CG onto the center line of the space allocation, and that's the point at which we're saying we're tracking, we're going to check the fill. So any cables that leave or exit at that space allocation won't contribute to fill further on in that space allocation, but any cable that goes across that point on the space allocation we will track. So I can select the a cable support. So our cable went up here. Now I'm not sure if my precision is actually high enough right now to support this. So I'll go to, so yeah, the single cable that I've got it's showing 0, and it's just simply because right now because my cable fill is below a readable amount on that number. So it's showing as 0. But as I build up the cable, this number will start to add up. And this number is a number from 0 to 1. So similar to the maximum fill here is specified as 0.8. And so the equivalent of 80%, and that's your fill shows here. The second place that fill is monitored is also in reports. You can either in pull sheets, sorry, not pull sheets for the cable. For cable support, there is a report, and you can print off the cable spaces and the fill at supports within those cable spaces. So does that answer your question, Octavian? Good. And there's, so I don't have time now to go to the cable spaces, but is there any other questions?
Nope,
Just give me a moment in case anybody wants to chime in.
We've had one question, just reports, question mark. You want a demonstration of reports or anything?
Do I have, I think I can do our reports here. Oops. So we've got one cable. Let's see what we, oops, sorry, so I go to the report module. So in terms of what is provided for reports, we have reports. You can report on cables. Cables are also, the cable report is also the primary, it is the means of generating the cable schedule. So we support two styles, a vertical, what we call the vertical style, which is essentially one page per cable. And then there's more of a spreadsheet style, which is just the cables listed vertically down the sheet, and with the cables, the actual list of legs that that cable goes through in one particular column on the side of that report. So let's see if we can give you a quick example here of the two. So that's in Unit 2. Oh, I haven't saved my cable drawing, that's why. Okay, so save my cable. Let's try this again. There we go. So this is an example. This is an example of the vertical pull sheet style. So I've got one cable with heading information across the top, and then I've got the cable path specified vertically down the sheet. So starting with the hanger that it enters at, then the legs that it goes through, and then the hanger that it leaves at again. Also, these are configurable columns, but I also have the cable space that it goes through and the length of each leg that it's traveling, so you can sort of see where the longer ones and the shorter ones are. And a quick example, let's see if the so this next one is one we call horizontal spreadsheet style. Probably would be more descriptive, but it simply lists, again, I've only got the one cable defined so far, but it would list the cables down the sheet, and then the route is just listed as a series of legs, and you can control whether you want to include the cable space as part of that leg definition at each point, or if you just want to list the legs to make it simpler, whichever suits you. So other reports, you can also report on cable supports. So you can get a list of cable supports in the model. And what else? There's one other cable supports, cables. So you can, there are just general cable reports as well. And I believe legs, I think legs is the other one. So you can get a list of legs, and for each leg you can get a list of the cable spaces and the supports in that leg. So George, does that answer your question, I hope? I'm gonna take it as a yes. So Norm, I think we're out of time now. Okay, George. Yeah, so he says good for now. So please follow up by all means with the Augie Marine, Nexus, or the product management email.
Okay, and yep, I just want to remind everyone a couple of weeks from now, on September 24th, we'll also be covering marine drafting. So I encourage you to sign up to that as well. And you can follow up with your dealer, of course, if you have any further questions. I encourage you to do that, keep them in the loop. And if that's everything, then thank you everyone for your time. Yeah, we'll conclude the webinar.
Yeah, thanks everyone for joining. I really appreciate it.
Great, thanks.